Okay, in this video we are going to look at how to use this solubility chart to determine what state symbol a substance needs. And so this chart is fairly simple to use. Across the top we have a list of cations, meaning positively charged ions, and across the side we have a list of anions, or negatively charged ions. And so we just need to take the two ions in our substance, pick the cation and the anion, and then run our fingers together until we get to one of the symbols on the chart. And you can see most of my chart here. The only part you can't see is the bottom, where it has the symbols IA, IB, and H2O. But the only one of those that we're really going to be concerned with in this class is the IA, which means soluble only in acid. Okay, so CaCl2. So the positive ion, or the cation, is the calcium, which has a +2 charge, and the chlorine is the negative ion, which has a -1 charge. So we're going to look across the top for calcium, and that's right here, and across the side for chlorine, which is right here. And then we're going to just bring our fingers together carefully, and the symbol that we get to when we bring our fingers together is S. S means soluble. So we get that symbol S, meaning soluble. If something is soluble, that means it's going to dissolve. So we need to put a state symbol that indicates that our substance is dissolved, and that state symbol that indicates that something is dissolved in water is aqueous, AQ. So if we get soluble on this chart, when we write our state symbol in our chemical equation, it's going to be AQ for aqueous. All right. Next we have FeS. So sulfur has a -2 charge. So iron's a transition metal, but since sulfur has a -2, iron must have a +2 charge. So at the top of our chart we're going to find iron, and notice that there are two irons up here. One of them is iron 3 with a +3 charge, and one of them is iron 2 with a +2 charge. So that is why it's important to note the charges of each of our elements, because transition metals can have more than one charge. So in this case we want iron 2. So iron 2 right here. We're going to find sulfur on the side. Sulfur is all the way down here at the bottom of our chart. So we're going to carefully bring my fingers together, and I got a symbol IA, and that means that this substance is soluble, but only if it's on the same side of the equation as an acid. Only with an acid. So, for instance, if we had iron 2 sulfide plus H2SO4, and those were on the same side of our chemical reaction, then this would be soluble, so we would put the symbol aqueous. But if we didn't have the H2SO4, so let's see that in a different color. If we didn't have H2SO4, then our symbol would have to be solid, because it wouldn't be soluble, it would be insoluble. So that was a little weird. So if you get the symbol IA, that means it's soluble only if it's with an acid. If there's no acid with it, then it gets an S for solid, meaning it's insoluble. Alright, next we have PbCO3. CO3 is carbonate, has a -2 charge, so lead must have a +2 charge. So let's look for lead, Pb, with a +2 charge, and then CO3 is on the edge of our chart. So we drag our fingers together, and once again we got Ia, meaning it's soluble only if it is with an acid. So once again, Ia, so our symbol is either going to be AQ if we have an acid, or it's going to be solid or insoluble if there's no acid. So I'll put both those options there, and you just have to pay attention to your chemical equation. Alright, next BaBr2. So Ba is right here. Bromine has -1, barium's +2, and bromine, let's find that on the edge. Having a hard time finding it. Br -1, I missed it. Barium bromide has an S. That S stands for soluble. So that does not stand for solid. Soluble just means that it is dissolved. So our state symbol is going to be AQ. And then last but not least, As2O3. Let's see. Oxygen has a -2 charge. 2 times 3 gives me 6. Divided by 2 gives me +3 on my arsenic. So I'm looking for arsenic. Oh, there it is. Arsenic with a +3 charge. And then oxygen -2 is right here. As and then O brings me to an I, which stands for insoluble. So if something is insoluble, that means it does not dissolve. So we're going to put the symbol S for solid, meaning it does not dissolve, it remains a solid.